this unit, we're going to continue our look at number sense. In this lesson, we're going to look at square roots. Okay, hi everybody. So in this lesson, we're going to take a look at square roots. Okay, so the root is also sometimes called a radical, particularly when we write it like this. That little symbol right there, okay, this is our radical. Well, the whole thing is radical once you've got your what we call our root index and the thing underneath here that we call our radicand. So in this case, we're taking the square root of a number. We know it's a square root because there's no number written in there in the little area in between that we open up. If there's no number in there, it's a square root. Now, perfect squares are numbers that are the square of another number. Okay, so if we take it to the power of 2, so here's a good example here. 3 squared, which really means 3 times 3 is going to be 9. Okay, so 9 is a perfect square. Now, we can be even a little bit clearer than that. Let me show you here kind of what this means here. Let's say we've got a square, and it's got a side length of 3 and a side length of 3. Well, we know that the area is going to be 3 times 3. Then what we do to write it, we're going to write the 3 once, but then we're going to put a little exponent of 2 on there to indicate that that 3 shows up as a factor twice. In other words, that 2 tells us that 3 is representing the length and the width. It's the same number for the length and the width. That's why we call it 3 squared, because when the length and the width are the same, the shape we're looking at is a square. Now, on the other hand, we can go the other direction here. What if I tell you that the area is equal to, let's say, 16? Well, then my side length is going to be the square root of 16. And that's what this symbol is really about producing here, is about going backwards from an area to a side length. Now, I know that 16 is the same as 4 times 4. 4 times 4. Now, and I know that because this is an area, and this represents the length, and this represents the width, okay, same number multiplied by itself here, that the side length is then going to be 4. It doesn't matter to me whether I'm talking about the length or the width, because they're going to be the same length for this particular shape. So this symbol right here, square root, okay, the square root, basically is saying if this is the area, what would my side length be? So it breaks it up into, basically we're taking that 16, we break it up into the same factor multiplied by itself twice, okay? So, well, multiplied by itself once really, but so 4 times 4, but we're only referring to the 1 4 because I don't care if it's the length or the width, it's the same value there. So that's what happens here. A perfect square has 2 equal factors. Now, you've probably got some square roots already memorized. So for example, what's the square root of 1? Well, you're probably already aware that that's 1. Okay, because 1 times 1 is going to be 1. What about the square root of 4? Well, that's going to be 2, because 4 is the same as 2 times 2. Square root of 9, probably already aware is 3, because that's going to be 9 is the same as 3 times 3. There's my length and my width. They're the same. So my side length is just going to be 3. And we can go up, and you probably can go for a little while here. 16, you're probably aware, is 4 times 4, so the square root of that's going to be 4. 25, 5 times 5, so the square root is 5. 36 is 6, and now you should be getting the sense of where I'm going with this. So you probably know 36, 49, 64, 81, 100. And I wouldn't be surprised if a few of you know 121 is 11 and 144, the square root is 12. I suspect a lot of people are comfortable up to about 12, and then they start to waver a little bit on what those values are. Okay, but it's just a matter of knowing your multiplication tables. So squaring and taking a root, taking a square root in particular, these are inverse processes, okay? They undo each other. So for example, if I start with 5 as a side length and I square it to get 25, I can then take the square root of 25 to undo that and go backwards to 5. Okay? Anyway, let's take a look at some questions. Okay, so for this question right here, we're going to use the calculator to determine the square roots, and we're going to round to the nearest tenth. So I just want to make sure that you can see how we're doing this with the calculator before we get into it. And actually, I'm going to grab two calculators here so you can have see what this looks like in two cases here. So the first of all, I've got my TI 84 plus, and I'm going to take the square root of 3. Now, for me to do that, I got to look for that square root button, and that's going to be right here. Okay, and it's just above the x squared button because these two operations are inverses of each other, like we just said here. So we group them together on the calculator. But for me to get that square root function here, I'm going to press second x squared, square root, and that opens up that square root symbol. I'll put a 3 in there, and then I'll press enter. And to the nearest tenth, I get, okay, I'm going to round that to 1.7. Oops. So this will be approximately 1.7. And then I just repeat the process here. Okay, so square root 17, press enter, and to the nearest tenth, that's going to round to 4.1. Now, let's pull out a scientific calculator to finish this off. So here's my pink calculator. This time I got to look for my square root button. It might not be in the same place, but I do expect it to be together with the x squared. So I do see my x squared, and there again, just above it is my square root button. So again, second x squared to access the square root button here. Now, notice that it drops a set of parentheses there. Okay, it drops the opening parentheses there. My other calculator didn't, because what the other calculator did was draw the bar along the top over top. The bar implies this set of parentheses. This calculator can't draw that on top here, so it opens up the parentheses there. And then I'm going to type in 41 and close the parentheses so it knows that that's all it's going to take the square root of. Press enter, and I get approximately 6.4. Now for this one over here, that negative is outside the square root. So the negative is actually going to happen later. Remember, just like I said here, that bar over top implies a set of parentheses around that, okay? Which means I'm going to do that first. So I'm going to clear that, press second x squared to open that up here, put 95 in, close it, and I know that that negative is going to happen after the fact, and that this will round to 9.7. Okay? So that's how you'd use your calculator. Now for this question, we're just going to determine the exact square root, or we're going to round to the nearest tenth if that's not possible. So we're going to try to do it without the calculator, but if we get stuck, we'll pull out the calculator here. So here, the square root of 49, well, I know that 49 is 7 times 7. Okay, so remember, this is basically saying if 49 is the area of a square, what would the side length be? And the answer here would be 7. That negative, again, don't get thrown off by that negative. There's a set of parentheses around what's underneath. So we're going to just take that, and then we'll apply that negative later. So the negative sits out front. 64, if 64 is the area, what would be the side length be? Well, it would be 8, because 8 times 8 is 64. And then the negative gets applied afterwards. Here, square root of negative 81. Now here, notice that the negative is now underneath the square root. So what I'm saying here is I'm saying that the area of my square is negative 81. What would the side length be? So what I'm saying here is my area is negative 81. So I've got some x here and I've got some x here. And when I multiply those two x's together, I'm getting a negative 81. But that should cause us to stop immediately, because let's just say that they're both positive. Well, a positive number times a positive number is going to be a positive number. Okay, well, clearly these aren't positive. If they're negative numbers, a negative times a negative would be a positive. Okay, well, clearly they're not negative either. Well, now I think about it. Numbers are either positive or negative, or they could be 0. Well, 0 times 0 is not negative 81. So something weird is going on here. Now, it turns out there is an answer to this problem, but it's what we call an imaginary number. Okay? It's a different kind of a number system. So for right now, what we're going to say here is this is what we call not real. It's not a real number. There is kind of no value for that. So at this point in time, with what we're looking at right now, we cannot take the square root of a negative number. That just doesn't work. Now, over here for this one, I've got the square root of 16 over 25. Now, because the way fractions work, a over b multiplied by c over d just becomes a times c over b times d. Because we just multiply the numerators to multiply the denominators here, when I take the square root, basically I'm taking the square root of the numerator and denominator separately. Okay, I multiply them out separately when I go forward. I'm going to treat them separately when I go backwards. So the square root of 16 is going to be 4. 4 times 4 is 16. The square root of 25 is 5. 5 times 5 is 25. So there we go. Now here for this one, 12 divided by 3. Okay, so what I was just doing here was splitting these up here. Well, the square root of 12, I don't know. The square root of 3, I don't know. But there is a set of parentheses here. And so I could have done this here, but I don't know what 16 divided by 25 is. But I do know, again, that I'm multiplying the numerators, multiplying the denominators. Now here, wait a minute, I do know what 12 divided by 3 is. That's 4. And the square root of 4 is 2. So in this particular case, I did have the ability to do a little bit of work here. So now when I think about this, 5 over 45, remember there's a set of parentheses there, I would see that as the square root of 1 over 9. Okay, because 5 over 45 simplifies down to 1 over 9. Now, I can't do much more with that, but I know that my numerator and my denominator I can kind of treat separately here. The square root of 1 is 1, and the square root of 9 is 3. Okay, we keep going here. What's the square root of 0? And it's very tempting for a lot of people. Because we identify that you can't take the square root of a negative, it's very tempting for people to assume that you can't take the square root of 0, but the truth is it's 0. Okay? 0 times 0. 7, root 7. Oh, well, 7 is a prime number. Okay, 7 is a prime number, so it doesn't have those two factors there. So I'm going to have to go to my calculator, tell it to take the square root of 7. And when I round that to the nearest tenth, like it says, I will get approximately 2.6. Now, over here, remember I've got parentheses around this. I've got the square root of 5 squared. Now, I could do this a couple of different ways. First of all, I can recognize that a square root is the opposite of squaring. So the square root symbol and the squaring will cancel each other out, and all you're left with is a 5. Or, honestly, I could just do that calculation. 5 squared is 25, and then the square root of 25 is 5. So either way, I'm going to get to the same spot. But if I recognize that, it makes other questions a little bit easier for me to do. So for example, for J here, okay, that negative is not inside the square root, so it's not causing me a problem that way. So the negative will come up later. And now I've got the square root of 15 squared. Well, okay, I could evaluate 15 squared and then take the square root. But I just saw an example where I could do that, but I didn't need to. So 15 squared, square root, those are going to cancel the square root and the square, so I'm going to be left with 15 with a negative out front. This one right here, the square root of 0.64. Now, you might recognize 0.64, okay, or 64 I should say, 64 as having a square root of 8, and yet you'd still look at this and wonder what on earth the answer is. So let's just take a quick look. Let's let the calculator do it right now and see if we can come up with a rule for it. So 0.64 square root, and I get 0.8. Now that I look at it and I think about it, yeah, that makes sense. Because if I multiply 8 by 8, I get 64. And since I've got one number behind the decimal, if I was to multiply this by another 0.8, I'd have two numbers behind the decimal, and so I move the decimal over 2 digits. Yeah, that makes perfect sense. And now last but not least here, I've got two radicals with a plus sign in between. Because of the parentheses here that would be implied, I'm going to evaluate these things first. The square root of 16 is going to be 4, plus the square root of 25 is 5. After I've done that, I would add those together to get 9 as my result. Now, another thing that we're going to want you to do here is to be able to estimate square roots. Okay? So here we go. And we're going to use the calculator actually in just a couple seconds here to confirm our estimates here, but we want to estimate square roots. And so we've got these 4 that we're going to estimate, and then we're going to drop them on the number line here. Okay? So the square root of 10, and what we mean by this is, I'm not going to go to my calculator first. I'm going to take a quick guess at this. And I'm going to guess to the nearest 10th. I'm going to guess. It's not going to be perfect here. I'm going to guess the nearest 10th here. But 10. I'm looking for the square root of 10. Well, I don't know what that is. But there is a number very close to 10 that I do know the square root of. 9. The square root of 9 is 3. Now, because 10 is a little bit bigger than 9, I expect my square root to be a little bit bigger than 3. Now, not quite up to 4, because 4 is the square root of 16. So I'm going to be somewhere in between. So let's just take a quick stab at this. Let's say that this is, here's my root 10. I'm going to guess that this is approximately, let's say 3.2. Okay? Now I'm going to go to my calculator. Square root of 10, and look at that. To the nearest 10th, that is in fact 3.2. Awesome. Now let's look at 110. Well, I don't know the square root of 110, but I do know the square root of 100. And the square root of 100 is 10, so I know this is going to be a little bit bigger than 10. The next one up is 121. That's the square of 11. Now let's just think about that. Between 110 and 111, okay, sorry, between 100 and 121, I should say. Wow, I can't believe I said that so wrong. Between 100 and 121, 110 is kind of in between. So I'm going to guess that this is maybe 10.5. That's right, 10.5. So I know that it's going to be somewhere around here. This is going to be my square root of 110. Now, let's take a quick look. How did I do? And there it is, 10.48. That is going to round to 10.5. Now, root 5. Well, the closest number to 5 that's a perfect square is 4. The square root of 4 is 2. So I think this is going to be slightly bigger than 2. I mean, the next one is going to be 9, and the square root of 9 is 3. So that's a little ways up here. So I'm going to guess here that this is, let's say it's really close to it. Let's say it's 2.1. Let's take a quick look here. Now, what is the square root of 5? Oh, that was a little off there. It's 2.2. Okay, so that's not right here. It's going to be approximately 2.2. But here's my root 5, just a little bit bigger than 2. And then over here is 70. And again, I want to think about the numbers that are closest to it. Below it, there's 64. And the square root of 64 is 8. Okay, above it would be 81. Okay, 81. And the square root of 81 is 9. So between 64 and 81, well, 70 is closer to 64. So I suspect my square root is going to be a little bit closer to 8. So I'm going to guess 8.3. Ah, 8.4. So I was close. 8.4. But that should give you a little bit of an idea as to how you would go about estimating the values of square roots. Okay, now we're just going to end this lesson here just by going through a handful of examples. Okay, just simplifying some expressions here. And so you're going to see sometimes we're going to throw some addition outside, sometimes inside and whatnot. Then we're going to move on and take a look at the Pythagorean theorem. Okay, so here we go. So because of the parentheses that are implied, what we're going to do is we're going to do the square roots here first. So the square root of 9 is going to be 3, and the square root of 16 is going to be 4, and then I would do the addition and get 7. But here, the parentheses are around everything underneath the radical, so I'm going to do the addition that shows up inside there first. And so 9 plus 16 is going to be 25, and the square root of 25 is 5. Here, because inside those parentheses there's no other operation, I'm just going to start with that. Now the negative is going to pop up afterwards, so the square root of 16 is going to be 4 with a negative in front. The square root of 4 is 2 with that subtraction in front, and so then negative 4 minus 2 will be negative 6. Similar sort of thing going on here, except that second term, that number there, there's no radical over it, so it's just going to stay the way it is. The square root of 64 is 8, and the negative applies afterwards, so negative 8 minus 16, and then we're going to get negative 24. Now, just like we were doing here, where the negative out in the front kind of applies afterwards, this 2 that sits out front gets applied afterwards. But notice it's written right up against the square root here. That implies it's multiplied. So the square root of 16 is 4, and that's going to be multiplied by that 2, in which case the answer here, the final answer, is 8. Similar sort of thing here. I'm going to do that square root first. Square root of 4 is going to be 2, and then I'm going to multiply by the 25 that's out front to get 50. Then over here, it doesn't matter if that number out front is negative. I'm still going to do that afterwards. So this is negative 5 multiplied by the square root of 4, which is 2, plus 10 multiplied by the square root of 9, which is 3. And again, I'm doing those first because there's that implied set of parentheses in there. Now I'm going to do the multiplication. So negative 5 times 2 is negative 10. 10 times 3 is going to be 30. And then negative 10 plus 30 is 20. Now, here is a question or two here using the Pythagorean theorem. I should draw in the right angles here. So we're just going to solve for the variable in both questions here. Now, in this case, c is the hypotenuse, and so I'm looking for c. That's the one unknown. So it's going to be 6 squared plus 8 squared is equal to c squared. Well, 6 squared is 36. 8 squared is 64. When I add those together, actually I'm going to get 100. And now, to get my answer, I'm going to take the square root of both sides. Because remember, I have to do the exact same thing to both sides of the equation. So, and the reason I'm choosing the square root is because I want to do the opposite of that square. I want to get rid of the square on the c. So the square root of c squared is just going to be c. And then on the left-hand side, the square root of 100 is 10. So my hypotenuse there is going to be 10. Now in this question, the thing that we're looking for isn't the hypotenuse. We know the hypotenuse. It's the square root of 3. So I would take the square root of 2 squared plus a squared is equal to root 3 squared. Now that's just me plugging in the values as I see them here. Now let's simplify this a little bit here. The square root of 2 squared, because these two are the opposites of each other, they cancel each other out here. I'm just going to be left with the 2 plus a squared is equal to, and the same thing happens over here. Because the square root and a square are opposite each other, I'm just going to be left with the 3. And now to figure out what a squared is, I'm going to subtract 2 from both sides. To move that over, 3 minus 2 is 1. And then I'm going to take the square root of both sides. Just like we did up here, the square root and the square cancel, so I'm left with a. And then the square root of 1 is just 1. And there's my final answer here. That's the leg of my triangle.